Hi, my name's Ian Voos. I'm a student at NC State University in MAE ECE 535, and here's my demo of electromagnetic relays. Relays act as electrically controlled switches. There are two main categories of solid state and electromagnetic, which I'll be discussing in this video. Electromagnetic relays are simple, cost-effective, and adaptable to different kinds of applications. They incorporate many of the fundamentals that we've discussed in class, particularly Lorenz's and Faraday's laws. And above you can see an example that is comparable to the relay that I'm going to demonstrate. So to construct my relay, I used magnet wire for the solenoid, a cylindrical ballpoint pin as my solenoid body, a steel bolt as my armature, some hookup wire in a helical shape for my spring, a Allen wrench for my fulcrum, and a popsicle stick for my lever. I did some analysis on my relay using FEMM. As we discussed in class, the maximum force that a solenoid can exert on a metal rod in this case is at the middle of the coil, as this is where the gradient is highest. For my scenario, at the midpoint of the coil, the force on the rod was approximately 0.05 newtons, and if the rod was fully inserted into the solenoid, the force was only about 0.005 newtons, which is 10 times less. Here's my demo relay in action. As you can see, as I'm turning on the power supply, the armature is drawn into the solenoid body and is pushed back out by the spring. This in turn moves the left side of the lever up and down, which is where the contacts would be in a real relay. To compare to a real manufactured relay, I used a Finder 30 series relay and took some basic measurements. I found that the resistance was approximately 125 ohms, the wire diameter was approximately 44 gauge, and the coil diameter was about 5.5 millimeters. So this led me to a 72.5 meter total length of wire, which equated to about 4,200 turns. During testing, I found that the nominal current was 40 milliamps, which is significantly less than the 2 amps that I needed to cause a significant effect on my armature, and that's because my coil only had 250 turns. So here's that relay in action. As you can see, the left side is being drawn into the solenoid as I turn on the power supply, which forces through lever action the top portion to contact that metal bar, which closes the external circuits. Thanks for listening.